Opcodes and Ethereum are critically important to smart contract developers. So if you are an existing or aspiring dApp developer or layer 2 protocol developer or someone willing to follow Ethereum's upcoming changes, continue listening. Welcome to PEEPanEIP episode 122. I'm Pooja Ranjan. Today we are going to talk about the 9th EIP considered for inclusion in the Dencun upgrade. Documented in September 2023 by Carl Behuizen, EIP-7516 is introducing Blobbasefee opcode. To learn more about the proposal and why that is important to layer 2 projects, we are joined by Ansgar Dietrichs. Welcome to PEEPanEIP, Ansgar.
Hey, happy to be here.
For our new listeners and followers, Ansgar is a researcher at Ethereum Foundation and co-author for multiple EIPs. He has been on our show earlier talking about EIP-2938 account abstraction, EIP-3074 auth and opcodes. If you have missed his earlier talks, check out the links in the description. It's wonderful to have you back, Ansgar, on the show. I hope to have a conversation on the proposed EIP and maybe get some insight on the latest research work. But before we get there, may I request you to give a brief introduction of your professional background and journey in the Ethereum ecosystem?
Sure, yeah, thank you. So basically, I've been an Ethereum core researcher for almost exactly 4 years now. That was my first job out of university, so I don't really have much of a professional background beyond that. Initially, I was at a different team called Quilt that was formerly inside Consensus, but was basically doing the same job roughly. And now since a year and a half ago, roughly, I'm at the Ethereum Foundation in the main research team. I do different kinds of research in the past that has kind of touched up on different things. You mentioned some of the EIPs we worked on in the past. For example, EIP-2938 that ended up turning into EIP-4337 that people might be familiar with. And then more recently, like in the past few months, I've been working on 2 topics that those are kind of scaling. So that's where the EIP-4844 comes in, but also then beyond that, and then also kind of Ethereum economics, and then layer 2 coordination. And so in a way, kind of this EIP is funnily enough sits kind of in the middle of all of these. Also, like last year, I worked on multidimensional fee markets. So kind of the whole Ethereum fee design has been something I've been dealing with in the past.
That is wonderful. I'm sure, like I have seen your earlier talks. It was awesome to understand how like account abstraction works and the proposal about 3074. And I'm looking forward to understand fee structure a little bit more here with respect to the present upgrade. So without further ado, let's begin.
Yeah, sure, of course. So basically, this EIP itself is a really, really tiny one. Of course, I assume most people listening to this or watching this will be familiar with EIP-4844, which is a really, really major upgrade. It adds an entire new type of transaction that comes with a special new type of data that we call blob data. Blob data is separate from normal data in Ethereum because it can't actually be accessed from inside Ethereum. We only attest to its availability. So that's like a completely new type of service we provide as Ethereum, and that will be crucially important in the future for scaling rollups. So EIP-4844 is a really big EIP, will be at the core of the upcoming Dencun update. And so over time, there were a few changes. Of course, and EIP always goes through an evolution. But then at some point, basically, you want to kind of finalize an EIP. So 4844 was finalized a couple months ago. And then only relatively recently, which unusually late in the process of say, hard fork planning, people raised the concern of like one specific missing feature. And because we had kind of already just made the decision to finalize the EIP and no longer make changes, instead of just adding the feature to the EIP, which we could have done, we ended up deciding to just create the small separate EIP. So that's why this basically is more, you can think of it as more like an edit to the bigger EIP. So this is really a small thing. It adds one extra opcode. And so now maybe we can have a look. Obviously, you already know what the opcode is called, Blobbasefee. Basically, one thing you should know is that the way fee markets work on Ethereum today is that you have gas, of course, that is used to basically account for the amount of effort that you cost for Ethereum for the EVM, and so you have to pay proportional to your total gas consumption. And the price you pay varies according to, like time of day, how much demand there is right now, and that is measured by what we call the base fee. So if you send a transaction, even if it takes the same amount of effort, say it's just a simple ETH transfer, right? That always consumes the same amount of gas. But if you send it while there's a lot of demand, you'll pay a higher price because the base fee will be higher. And if there's less demand right now, you'll pay a lower price because the base fee is lower. So the base fee is basically what usually sets the price for sending transactions. Now, as I was saying, this new EIP we are introducing, 4844, introduces this entirely new type of data, new type of transactions. And one aspect of that is that we will basically, for this new type of data specifically, we will not charge using the existing gas mechanism. So it's also a normal transaction, so it has EVM execution. For that, you pay normally, but then for this special type of data, you pay in a completely separate. You can imagine, like if you have a gas tank in your car, and that's usually consumed for whatever, right turns, left turns, acceleration, braking, all of that, kind of consumes the same gas out of the same gas tank. But then you could imagine you just have maybe you think of it as like a hybrid car. You also have a battery now in the car, and so that's just like a completely independent system. Maybe the analogy is not great because usually in a hybrid car you also use it to turn left and turn right. Say you have like a completely separate second gas tank in your car, and that one is only used for the blinker. Right, blinker fluid, say, So the separate gas tank, it pays for one other separate thing, and that's what we're doing with Ethereum now. So basically, you have the normal gas that you do pay for everything that you're used to, and then we have the data gas that we use where you pay for this type of transaction. Now, why was there an oversight? What did you in a way forget about, or initially decided not to include, and now this EIP kind of rectifies? Well, it's kind of always nice from inside the EVM to be able to access some context information about what the current state of the system is. And in particular, there is an opcode already in the EVM that's called base fee. And that gives you the normal base fee, right? The base fee that we use to pay for normal gas. So you can, as you send a transaction, the transaction can introspect and find out how expensive was the act of sending me. And that can be really helpful. Say, for example, if you're a DApp or something and you want to subsidize, say you're a DAO, right? And you want to subsidize the sending of transaction. There's some sort of proposal execution or something, and anyone can send the transaction and you want to just reimburse them, right? It's really important that you are able to find out how expensive the transaction was, so you can then reimburse that. And so for that, this opcode is usually used for similar things. Now, one special case, like one really big dApp basically on Ethereum is of course a layer 2, right? A layer 2 is of course its own separate blockchain, but then from the perspective of Ethereum, it is also just a normal application. It goes to Ethereum, it settles its rollup state on Ethereum. And for that, basically, instead of just it being one person that pays for that directly, usually those costs are then shared with all the users that send a transaction on the rollup, right? So if you send a transaction on the rollup, part of the fee you pay goes for actually the inclusion cost on layer 1. Now, so far, traditionally on Ethereum, because everything is only metered in the normal gas, rollups always use this base fee opcode to basically introspect how expensive is the settlement transaction, and then they forward those costs to their rollup users, right? If you don't do this, you would have to have some sort of inbuilt trust in the system, right? Ideally, users don't have to trust that the operator charges them correctly, so you want to have this trustless way of getting at that information. And the thing that people pointed out now is that once we have this EIP-4844, we have a new type of gas, a new type of tank. Now, rollup settlement operations basically have to pay types of gas. They pay the normal gas because they do still the normal operations on the EVM, but then they also pay out of this new gas tank, right? And so users on a rollup will now have to be charged for basically both of these types. Of course, the idea is that the contribution to the normal gas goes down, and so overall it gets cheaper for the user, but now it's still, they basically have to pay for the normal gas consumption of the settlement operations on Ethereum and this data gas operation. Now, the problem is that for the data gas, we just basically did not originally include an opcode like base fee to see what the fee level for that separate type of gas is, right? So basically, there you'd have to have some sort of indirect mechanism. Either you have to trust the operator, or you could retroactively introspect. You could have some sort of fraud proving mechanism, but it's just more clumsy. And of course, the reason we did this originally was just to keep the EIP simple. But rollups came to us and were like, hey, this is not ideal. We ideally want to be able to just have a direct equivalent to the base fee opcode for the blob gas as well. And so even though it was already relatively late in the process for the hard fork, we decided to add this extra opcode. Again, kind of the reason why we have it is a bit more complicated. That's why I kind of gave this entire overview. The opcode itself is really trivial. So it's just an opcode, you call it, it costs 2 gas, which is really cheap, because all it does is it just looks up the value, the current cost for this data dimension, which, it's right in the program. So all it does is it just takes that, puts it onto the what we call the stack in Ethereum, basically, so it can be accessed now by the smart contract. Really, really simple opcode, tiny change. That's why clients were also willing to add it to the Dencun update, even though we were relatively late in the process. But again, the rationale, for that to make sense, you really have to understand how layer 2s work, how the settlement works, all these kind of things. And maybe as one last thing before we then can go maybe more into questions or something. But of course, for you as a normal user, this will most likely never be relevant, right? Or at least not directly. Of course, you might be a layer 2 user, in which case it's indirectly relevant because the layer 2 uses it, but you don't have to implement it yourself. If you just write a normal Solidity contract or something, you will usually never use this opcode or the corresponding Solidity function, just because you will usually never use the special data, the special type of data, because it's only really useful for rollups. And so you don't care how expensive it is normally, right? But it's still very important that we have it so that the specific type of users, namely the layer 2s, can use it to make all of their accounting more clean and trustless. I don't know, this was a lot jumping back and forth, but I hope that kind of roughly made sense.
It does. Thank you so much for sharing all this information. This was a short proposal, as you mentioned it in the beginning of the call. And it is really good to have separate proposal rather than having the one proposal making it even longer and more complex. So it's really nice to see this one short, sweet, and simple. Thank you for sharing. We have some participants on the call, guys. If you guys have any question, please feel free to drop it in the chat, and I would love to invite you to maybe take it independently with the guest. But in the meantime, I have a few more questions. Well, I would like to start today's question answer session with the first question based on your thoughts on these opcodes. As we know, despite being recently added to the upgrade, the discussion tool link of this proposal has quite a few comments, and those are valuable. I'm curious to follow your general thoughts on special cases versus general form of exposing EVM context information.
This is actually a really good question. That's a great point, because actually I think that might have even been my comment initially, at least, because indeed, that was, I totally forgot to mention this in my overview here, but there was a question basically when this was raised that we would want this. Of course, we already have a base fee opcode. Now we introduce this next blob base fee opcode. You could imagine in the future, maybe we have 1 or 2 more of these types of data of gas, right? You could imagine our car getting really complicated, and now you have 4 different types of tank. And it's, in a way, it's a little annoying to introduce a separate opcode for each of these, right? You could imagine, for example, we were thinking what one alternative that you could do is you just have an opcode that's that lets you access all the base fees, and you tell it which one you're interested in. So right now, both the base fee and base fee opcode, they do not take in any arguments, right? So that's why here input it says 0, and because you're there's no extra thing you have to specify. You want the blob base fee. There's nothing to specify. But what we could have done instead would be a base fees or something opcode where you basically tell it which base fee do you want. So for example, we could have said, if you put in a 0 on the stack, then you get the normal base fee. If you put in a 1, you get the blob base fee. If in the future, maybe you put in a 2, you get this even fancier type of base fee for this third type of tank that we might add in the future. And that way, we would only have to have one new opcode, but then never in the future have to add extra opcodes like this again. So this would have been a generalization. At the same time, it just felt like we were not so sure whether there'll ever be extra types of gas in Ethereum. So it's not clear whether this will be useful at all. We still have quite a few spare opcodes, so it's not like we have to ration these very carefully. And in a way, it would have been a bit redundant, because you would get access to the normal base fee, and we already have a separate opcode. And of course, on Ethereum, you can only ever really add features. We can't remove them. So we could not have done some sort of cleanup where we just removed the normal base fee opcode. So we would have just basically had redundant functionality. So that's why we decided against that specifically, and also to keep the EIP as simple as possible to still make it into Dencun. There was one other consideration that maybe is also worth mentioning. And so in a more general sense, right? I think you phrased the question really well of like just like generalized context information access, because you could imagine, maybe someone is not just interested in the base fee, but some other parameter of the overall context, like it's just as we already give people access to the remaining gas and these kind of things. So like, what if there's other types that we just haven't made available yet that we would want to make available? In that sense, what if we basically, instead of introducing an opcode just for the base, we just introduce something that gives you very generalized access? At that point, probably an opcode would no longer be suitable, just because it would be too complex functionality. What we could have done there instead, and people have talked about this in the past, it could be some sort of system contract where you call into it, and then as part of the call, you specify what, via some sort of API interface, what context information you want, and then you get that information returned from that contract. That was also something, but again, the idea here was to say that if we were to go this path, it's probably just too late for this hard fork. So we would have to postpone, and then we would have a few months, like, you know how irregular hard forks in Ethereum are. So who knows really when the next hard fork will be? It could be a few months, it could be basically a year later, So it would just be really unfortunate if rollups would have to wait this long. So the idea is we might still do this. We might still add a system contract like this in the future. But then the thinking was having this one-time extra opcode, even if it's then maybe redundant going forward, it's just good enough. It basically, it's worth the trade-off just to get this out of the door now. But it is a really interesting, I think, conversation, and we should definitely keep the conversation up, because sometimes with these things, there's always the temptation to only talk about it as it comes up, but usually it comes up close to hard forks when it is too late. So I think ideally we should try and keep investigating this now, even if it won't be relevant for this hard fork. But it's a really good question.
Given the present circumstances where EIP-7516 is being considered for inclusion to Dencun upgrade, do you see any benefit in pursuing the alternate idea, the idea of having opcodes future-proof? Do you think people should follow the idea after the upgrade, given EVM team has their own set of proposed changes as priority for the Prague upgrade? Where do you see this idea of future-proof EVM opcode?
Well, so that's why I think it's important to briefly drill down on basically the specific procedure here. So this opcode, basically, this EIP was proposed at a time where we had already started to we kind of already had finalized the set of changes for the upcoming Dencun hard fork. And because this was such a priority, though, we basically reopened Dencun, added this EIP, and now it's basically already a done deal. So this will ship as part of I mean, of course, there's always a small chance something goes wrong and we end up deciding last minute to kick something back out, but all going as it should. And this EIP will be shipped as it is today, as you can see it here, with the upcoming hard fork that will hopefully come very soon. So in that sense, basically, we already passed the point where we would talk about maybe changing it, modifying it, combining it with some other features, like, for example, the upcoming, you mentioned it, like the Ethereum object format and the changes that are proposed there. And it could have made sense, but now it will be its own separate thing. It will come sooner. And then I still think that these future changes, they might still come with further improvements, like these more standardized ways of accessing this information. But this EIP, as you see it today, will, like, by all likelihood, it's already implemented. It will by all likelihood ship as is in the next hard fork.
It's good to know that it has already been implemented. I'm curious to understand its status with respect to the devnets that we have. With respect to devnet 9 or devnet 10, do you think this proposal has been included? And if so, was there any specific observation on this devnet that you would like to share with respect to this particular proposal?
That's a good question. I mean, actually, maybe Ahmad can briefly confirm. I'm the impression that it should be part of the devnets. Because the devnets really
part
are
of the devnet.
Okay.
That's for sure.
Okay. I'm not quite sure which devnet it was first.
I believe it was introduced in devnet 9, but there are no particular observations regarding this opcode. Yeah, but it was included in devnets, that's for sure.
Okay, yeah, that makes sense. Because by now the devnets really should exactly present the upcoming hard fork. And it's not surprising that there are no specific observations with regards to the opcode either, just because, as I was saying, technically it's really, really tiny. So there's no surface, or basically no surface for any issues. And that's the only reason why we even end up kind of adding it to the hard fork so late in the process, just because it was so clearly tiny without complicating the hard fork further. Yeah.
It's good to know that it was already tested on DevNet 9, because I understand we are currently in DevNet 10, and perhaps after DevNet 10, we will be forking the public testnet. So it's good to know that it's being tested. There was this comment on a Fellowship of Ethereum Magician page with respect to the expected range of values it returns. I wonder if it is something that needs to be a part of EIP, or if this is something that keeps on varying and will depend upon the developer.
Right. So basically, this is something that it does not affect the functioning of the EIP. This is more like an informational addition. So you might still end up editing the document just to specify to clarify this. And basically, whenever you put something on the stack on Ethereum, so basically the EVM is a stack machine. So you put a value on the stack. The stack in Ethereum is 256 bits. So it's really can be really big numbers. Of course, in reality, this is a base fee. So this represents some amount of ETH that you're supposed to pay for data. And so there's some realistic natural upper limit for how high this value can be, but which is much smaller than it could fit onto the stack, basically. And so there might still be a value in saying, hey, by the way, you can rely on that this number will never be bigger than this amount. Just because then people kind of dealing with tooling around the EVM can basically have logic in place that relies on this. So this is kind of like more of a hint for the functionality that might be worth adding, but it doesn't affect functionality. So that's why we haven't really paid attention to this so far. But really good point about it. I'm not sure I even saw the comment in the past. So good that I'm aware of it now. Right.
Maybe on a similar context, I'm trying to understand how stable we see this spec of this proposal is, and also of the EIP-4844, because this proposal 7516 is considered to be an extension, or perhaps, as you mentioned, was like addition of a missing feature of EIP-4844. Do you guys think that this is relatively in a stable state and we should not be expecting any further spec change following the comments of Fellowship of Ethereum Magician, of course?
Yes, so this specific EIP will, with like basic certainty, will not see any changes anymore. As you can see, it was created mid-September. Now we are in late October. And so mid-September was already pretty late in the process. Now there will be not any changes. EIP-4844 itself, basically same answer. There's one small exception, and that is we have this one parameter specifically in the EIP that is the maximum throughput. And so that from the very beginning, the understanding there was that we have set some values there. And if you're familiar with the EIP, there's basically the question is how many blobs can there be at most in one Ethereum block? And we set this value to be 6. So there can be at most 6 blobs, which is 750 kilobytes of data as part of an Ethereum block. But that was always with the understanding that this is somewhat optimistic. We are reasonably confident that this is good enough, can be shipped, but there's a small chance that looking at the devnets and then maybe even the testnets, depending on how late in the process we would change it, if we see some instability there or like some just network degradation that we don't fully like and are not 100% comfortable with, there could still be a change where we slightly reduce this from 6 to 4 as maximum throughput. So this is the one change that might yet happen to the EIP before we bring it to mainnet. But other than that, everything's stable.
I think this is under discussion and under consideration for quite some time, because I remember having a conversation with Terence when we started talking about EIP-4844, then it was like 2.4. Then when we talked to Gajendra Singh, it was like 3.6. Now, like testing team, I don't know, between 4 and 6. I hope team makes a decision real soon, and maybe before getting it onto the public testnet. It would be really nice to have specs frozen there.
I agree. And just for context, by the way, of course, people remember there was a short moment in time where we thought that we might even be able to ship EIP-4844 with the Shanghai upgrade earlier in the year that unlocked withdrawals from the beacon chain. And of course, because it would have been a bit rushed, there we would have definitely gone with the more conservative throughput numbers. Now that we knew that we would only ship it somewhat later and we would have more time for testing, we went from these conservative values to the higher values, but with understanding again. But we might have to go back down.
All right. I think it's a good idea to maybe get it into a stable state, and going conservative is also not bad, but withdrawal was its own set of packages. Glad that it is coming up separately. I understand EIP-4844 and also EIP-7516 is more relevant to layer 2 projects. I'm just trying to understand here, will it make any difference in the transaction cost for a normal user, not on layer 2, but directly on the Ethereum mainnet?
Good question. So, of course, this EIP itself is only a small kind of helper to the other EIPs. So, of course, the question really is kind of, as you said, right? Like, how will EIP-4844 impact things? And so, the bigger impact will definitely be on layer 2 users, because, so in a way, like, it's not that easy to understand the situation with the two tanks, right? Like, the more formal way of saying this is that we are introducing a second P dimension on Ethereum. So far, the Ethereum P market has been one-dimensional. Now it will be two-dimensional. The impact that has is that you can imagine if there's, say, for example, a big NFT mint, right? Some project launches and they have an NFT mint and everyone is rushing in to mint the NFT. Then usually the base fee shoots up very high on mainnet because everyone wants to go get in, right? And it's very high for transactions. Then at the same time, if I'm a user and I'm transacting on some layer 2, Optimism, Arbitrum, zkSync, whatever, your favorite layer 2. I am also hit by that because the layer 2 comes to Ethereum, has to basically do the settlement transaction, and now has to compete with all these NFT people for transaction space. And so basically the amount of activity on layer 1 impacts layer 2 users. Now, with the second fee dimension, now basically you can imagine these worlds are basically separate. It's not fully separate because part of the settlement transaction is still normal computation, but that's really small. The much bigger cost for layer 2 settlement is this data. And now this data just gets its own price. So even if, like, say, with NFT drop, the normal base fee shoots up by tenfold, right? Goes up by 10x, but the database would stay unchanged, right? So you could still settle layer 2 transactions at basically the same price. So basically, of course, you asked the other way around, right? You asked how are mainnet users impacted. But the first answer I want to give is, this is the reason why for layer 2s, for users on layer 2s now, it becomes just cheaper, but then also less variable in the cost. So you're no longer impacted by the variance on layer 1. Now, is there also an impact the other way around? In some way, yes, because now also there's less space on mainnet that is taken up by these settlement transactions because they get their separate data space. It is going to be less of an impact though, just because right now, if you look at how much usage on Ethereum is layer 2 settlement transactions versus normal transactions, the vast majority of gas is still spent by normal transactions. So those, of course, will still be there and compete for the same space. Basically, the demand will go a little bit down because the layer 2 people will now get their own space. So you could expect that basically all else being equal, Ethereum transaction would become slightly cheaper for normal users as well, for non-layer 2 users, but presumably this will not be a big effect and might just be dwarfed by whatever else. Like if we have just some more hype coming to blockchains, this might just increase overall demand, or if just the other way around, if people are just not feeling so happy about blockchains. So these are the kind of overall fluctuations that might just make a much bigger impact than this. But you are, in a way, like with your question, you are right that while this is primarily going to make layer 2 transactions cheaper, it will also make layer 1 transactions slightly cheaper.
Word cheaper is good for users. They are definitely going to be happy to know about it. And I hope the tools and the tooling and matrices around will be able to help us understand where we are with respect to, the transaction cost that can inspire more user to move towards L2 or maybe towards the Ethereum engine. We'll see it in the future. I know you're not the author of the proposal, but there's just one piece of information I would like to share with you is about the review status. Currently, the proposal is in the draft status, and we understand that we are close to the public testnet, which is like the last call status. So my recommendation for the author and the team working behind this proposal is to move the proposal to the review status as soon as possible, and they should be able to move it to the last call as and when we fork any public testnet.
Yeah, that's a really good point. I think it's just because it was such a small EIP, no one really paid that much attention to the specifics there. But of course, you're right. Just because it's small EIP doesn't mean we should not follow the proper process. I'll forward that, and we will actually get this out of draft. This is actually we overlooked this. So good to point that out. Thanks.
Yeah, we are just trying to make sure that we are not overburdening authors by getting into nits and bits of the EIP process of standardization, but high level of standardization, if maintained, will become a practice and it will become easier for people to follow along the future.
So yeah, I totally agree.
So if you would like, you can also plug in about the new layer 2 calls that's going on. Maybe people can follow about the time when it is happening.
Of course, yeah, good point. So, and I mean, I guess, if what I just said basically makes you think that, oh, yes, I should pay more attention to layer 2s, then you're in luck because yet another colleague or two other colleagues and I, Carl Bakers and your Weiss, we just also 2 weeks ago or so, last week, we started the call is called Roll Call. It's a monthly call that basically tries to bring all the layer 2 teams together and just talk about all things related to EVM standardization or broader layer 2 standardization. And so the idea is that I think we've seen a lot of kind of just experimentation in the layer 2 space, and that's exactly, I think, what the roll-up-centric roadmap was for to give each team the freedom to experiment. But I think now that a lot of teams kind of have already seen what works, what doesn't work, there's also a lot of just interest in, of course, voluntary standardization. This is not about us dictating a standardization. It's just to give a forum for on those topics where the roll-ups team actually want to collaborate. They can just come together and agree to common standards for more advanced features, and so keep Ethereum kind of growing in the best possible way, while keeping as much of the tooling and wallets and everything compatible with as many of the layer 2s as possible. I think it's a good effort, and we so far we've only had one call. We don't yet have live streaming set up. That will probably happen soon. For now, but I think there's a recording. So if you're interested, you can see the recording, and hopefully by the next time we have the next call, we'll already have live streaming. Otherwise, again, there will be recordings shortly after. Or reach out to me or Carl or Joaf if you want to be added to the calls, if you are someone that more actively works on these topics directly.
That's awesome. It's always a good idea to follow these public calls. This contains a lot of information and also provides the opportunity to anyone who would like to contribute or maybe share their thoughts and ideas with the developers. So stay tuned. Here in the chat, I see a question from Ahmed. Ahmed, if you would like to read your question for the guest.
Yeah, I just wanted to ask Ansgar about what he thinks L2s are going to do with these EIPs that are like L1 specific, like this one, for example, and others like 4844, etc. All of these EIPs bring over to the EVM some opcodes that only make sense in the layer 1. So what do you think, with their striving to follow Ethereum equivalence, and everyone's trying to use that term, what are they going to do with these opcodes and EIPs?
Right. This is actually a great question. We will have an in-person session on this kind of layer 2 collaboration, and I'll probably put it on the list actually because I do think it's not obvious what the answer here should be, right? Obviously, it does make sense to just copy it as is, because layer 2s do not natively have equivalent functionality. Like they don't have a beacon chain, they don't have the kind of blob data. Some layer 2s are experimenting with basically providing their own type of data availability and basically enabling layer 3s on top of them. And so they might be tempted to basically copy this to use it for this purpose, but most layer 2s, of course, don't. So I don't think it makes sense, but then kind of handling this in a standardized way, right? Basically, do you just ignore this? Do you assign some other functionality to it? I think actually this would make a lot of sense to standardize, because right now I think every layer 2 just makes their own pragmatic decision on this. Maybe one thing there that's interesting to mention, because of course, EIP-4844 itself also introduces new opcodes precompiled and a new transaction type. And the new transaction type is interesting because, again, it's the first transaction type that has the second fee dimension. So the 2-dimensional fee system, which no other transaction type has. Every other transaction type only has 1 dimension of fees. There is actually one intention of how we designed this transaction type was that we could at least adapt this and reuse it in the layer 2 context, because for layer 2s, it would also be really nice to have some sort of way to distinguish between the cost. Like when you send a transaction on layer 2, there's a portion of the cost that goes to layer 1 settlement, right? That's exactly what we talked about in the past year. And then there's a separate second aspect that just goes to the layer 2 internal cost. So of course, layer 2 is also a blockchain, and so it has its own cost. So you pay for two things separately. And right now they're all kind of crammed into this one value because, it's the way the layer 2s work is they just copy at the architecture from layer 1. Layer 1 only knows one fee dimension, so it's all in one value, but that leads to some issues. Like, for example, you can actually pay attention. It's quite interesting. For example, send a transaction on an optimism chain, like optimism itself or base or something. If you look at, in your MetaMask or something, you look at before you send a transaction, what it says, what the maximum cost is that the transaction might charge. And then you send the transaction, and then you look at Etherscan or the equivalent for the rollup, how much you actually ended up paying. You will be surprised to see that you actually ended up paying more, in most cases at least, than MetaMask predicted you would have to pay. Because actually what happens is that they charge you, the thing that MetaMask sees is only the layer 2 internal cost. And then afterwards, at the end of the transaction, they just take out the layer 1 settlement cost out of your balance. So they basically just charge it by taking it directly out of your account. Which is interesting, but again, it's just because so far there was no way to charge two separate prices of two separate things in one transaction. So that's kind of they hacked the way around this. But now that we for the first time have a two-dimensional transaction type, it would be really nice to use that and basically make this more explicit. So that similar to how on layer 1 you can use this transaction type to pay for normal execution and then the blob data. On layer 2, you could use a transaction type like that to pay for layer 1 commitment cost and layer 2 cost. Now the question is, would they just literally use the 4844 transaction type, with the same official kind of type byte and everything, and just interpret it that way? That might be slightly unelegant because it overloads the same transaction type for two different meanings, depending on which chain you're on. Or does it mean we just basically copy the transaction type and add a new version that explicitly is for that purpose? That's an open question, but at least it goes to the point of like, what do you do about this weird functionality that Ethereum mainnet has that just does not make any sense to just copy over to the layer 2. I think it's a really interesting topic.
That was awesome.
So yeah,
don't worry about it. That was awesome. Thank you.
And yeah, and it's actually, by the way, a great pointer because I completely forgot about this as a topic to bring up. So I made a note just now to try and bring this up in the simple. So thanks for raising that.
No worries.
I'm sure developers at Istanbul are going to have a great conversation around layer 2s and proposal, and we hope to see some short videos released very soon. So other people who may not be able to join at Istanbul be able to follow the decisions or whatever conversation happened over there. Looking forward to follow them.
Specifically, I'm not sure when exactly this recording will be released, whether that's even before DevConnect or not. But of course, with kind of recent geopolitical events, there's also some uncertainty. I know that some community members will not be able to make it to DevConnect that were initially planning to attend. So I think obviously we organize an event, but also other people, I've heard that I think we will really focus on trying to either like find ways to enable remote participation or at the very least kind of have good recordings and everything. So of course, to take into account that not everyone will be able to make it to the in-person events.
Right. We recently followed the Ethereum Foundation blog post as an advisory looking into the current global situation. It would be difficult for certain people, but I'm glad that we do have some video recordings to be followed later. All right. It's almost time to wrap up. Do you have any message for the developers community?
No, I would just say, I think just yet another sign that, of course, the future of Ethereum is very much kind of focused on. And so if you're a developer, you should probably, I think mainnet is a great place, of course. And I still use mainnet, but also over time, more and more activity will move to layer 2s. We are very actively working on these changes that enable more scaling on layer 2s. And I don't want to talk about this too much, of course, but we already, I think, make really good progress on moving beyond the scale that 4844 will give us. We have some really exciting, I think, proposals. For example, if you go look on ETH Research, Francesco and I 2 days ago published one specific proposal for what we call, so basically the next step after 4844 would be to move to data availability sampling, which is a much more efficient technique to ensure the availability of blobs. Once we get there, we will have much higher throughput for layer 2s to use. And so basically my message would just be that I think we are really kind of about to get quite serious about the scope for layer 2s. And so as a developer, I would make sure that at least I do not exclusively focus on mainnet with my attention. That's what I would say.
That is a beautiful message. All right. Having a futuristic vision to create a perfect blockchain ecosystem, Ethereum protocol developers are introducing EIP-4844 for data availability for layer 2 projects. Going on even more adventurous, protocol developers are considering opcodes for layer 2 projects to estimate base fees in the same upgrade. This is really commendable. Ansgar, we thank you for joining us on PEEPanEIP and talking about execution layer proposal 7516. We look forward to follow DevNet 10 and see the results of the testing of this, and maybe we see public testnet coming up real soon. We hope the proposal to be deployed on the Ethereum mainnet with the Dencun upgrade. On this note, thank you to all our YouTube viewers for watching and podcast subscriber for listening to this Dencun special episode on Ethereum Cat Herders YouTube. Should you have any question on this or any other topic, let us know at Cat Herders Discord. Check out description for more info. We'll be back with another interesting talk. Until next time, keep watching, keep listening, and keep sharing your love with Ethereum Cat Herders. Thank you so much.